NASA's spacecraft will pass closer to the center of our solar system than any human-made object ever.
But past the closest a human-made object has ever come to the sun, moving at a mind-bending.
A NASA probe is about to make history by flying closer to the sun than any spacecraft before.
On Christmas Eve, December 24th, 2024, NASA's Parker Solar Probe once again made history by venturing closer to the sun than any spacecraft ever had before. This extraordinary milestone, a testament to humanity's relentless quest to understand our nearest star, brought the probe to within just 3.8 million miles, 6.1 million kilometers, of the sun's surface. To put this achievement in perspective, that is roughly one-tenth the distance between Mercury and the sun, a region of extreme temperatures and immense challenges for both technology and human ingenuity. This flyby, the 20-second close encounter of Parker's daring mission, was not just a routine event. It was historic, as it marked the closest the probe has ever been, or will ever be, to the sun. NASA scientists meticulously planned for this event, expecting it to occur precisely at 6:53 a.m. Eastern Standard Time, 11:53 Greenwich Mean Time. However, during such perilous close approaches, the sun's intense radiation and magnetic interference create a radio silence, temporarily severing communication with the spacecraft. NASA will only confirm the probe's survival after it reestablishes contact, anticipated on December 27th. Since its launch on August 12, 2018, the Parker Solar Probe has repeatedly shattered records, pushing the limits of engineering and exploration. On September 21, 2023, it became the fastest human-made object ever, reaching an incredible speed of 394,436 miles per hour, 635,000 kilometers per hour, more than 635 times faster than a Lockheed Martin F-35 fighter jet. During its historic flyby on Christmas Eve, 2024, NASA's Parker Solar Probe not only ventured closer to the sun than any spacecraft before it but also shattered its own speed record. The probe reached an astonishing velocity of 430,000 miles per hour, 692,000 kilometers per hour, a speed so incredible that it could theoretically travel from New York City to Los Angeles in just 20 seconds. Achieving such speeds is not merely a feat of propulsion but rather the result of a series of carefully orchestrated gravitational assists, also known as gravity boosts. These boosts were provided by 7 strategic flybys of Venus, with the most recent occurring in November 2024, just weeks before the record-breaking close approach. Each flyby allowed the spacecraft to gain speed and adjust its trajectory, inching closer to the sun's fiery atmosphere. While breaking records is remarkable, the Parker Solar Probe's primary mission goes beyond speed and proximity. Its main objective is to study the sun's outer atmosphere, the corona, a region that defies conventional understanding of stellar physics. Normally, temperatures decrease as one moves away from a heat source. This principle holds true within the sun's inner layers. The core, where nuclear fusion occurs, reaches temperatures of around 27 million degrees Fahrenheit, 15 million degrees Celsius, while the radiative and convection zones surrounding it are progressively cooler. However, this trend inexplicably reverses in the sun's outer layers. The photosphere, the visible surface of the sun, has a temperature of about 7,400 degrees Fahrenheit, 4,000 degrees Celsius, but in the corona, temperatures soar to millions of degrees. This mysterious phenomenon remains one of the greatest puzzles in astrophysics, and Parker's unprecedented journey aims to provide critical insights into this and other solar mysteries. Yet, the sun's corona, located thousands of miles farther from the core, defies expectations by being significantly hotter, with temperatures soaring above 2 million degrees Fahrenheit, 1.1 million degrees Celsius. This enigma, known as the coronal heating problem, has puzzled scientists for decades. It's akin to discovering that a kitchen grows hotter the farther you move away from the oven, an observation that seems to defy logic and demands an explanation. At the heart of the Parker Solar Probe's mission is the quest to answer a crucial question: what mechanism heats the corona to such extreme temperatures? Several hypotheses have emerged over the years, though none have been definitively proven. One leading theory involves magnetic reconnection, a process in which the sun's magnetic field lines break and reconnect, releasing vast amounts of energy as heat. Another hypothesis points to Alfvén waves, magnetized plasma waves originating from the sun's surface, which could transfer energy into the corona. Both phenomena are deeply tied to the sun's dynamic magnetic field, which constantly shifts and interacts with charged particles in the solar atmosphere. By traveling closer to the sun than any spacecraft in history, the Parker Solar Probe is uniquely positioned to collect data that could unlock this mystery. Equipped with a suite of cutting-edge instruments, the spacecraft can measure the sun's magnetic fields, solar wind, and energetic particles with unprecedented precision. These measurements are crucial for understanding the processes powering the corona's extreme temperatures. Such a mission would be impossible without the probe's revolutionary thermal protection system, TPS. This state-of-the-art shield allows Parker to endure the sun's intense heat and radiation, safeguarding its instruments and enabling it to explore regions of the solar system that were once thought to be unreachable. Through this daring journey, Parker is advancing our understanding of the sun and addressing one of the most enduring mysteries in astrophysics. The Parker Solar Probe is engineered to endure the sun's extreme conditions, withstanding temperatures as high as 1,300 degrees Fahrenheit 700 degrees Celsius during its closest approaches. This is made possible by its revolutionary heat shield, crafted from carbon composite materials, which keeps the spacecraft's instruments at a relatively cool 85 degrees Fahrenheit 30 degrees Celsius. Supporting this shield is an autonomous cooling system that pumps water through radiators to dissipate heat effectively. Additionally, a sun-facing sensor ensures the heat shield remains perfectly aligned to protect the spacecraft, triggering automatic corrections if the probe veers off course. While the Christmas Eve 2024 flyby marked Parker's closest approach to the sun, its mission is far from over. 2 additional close encounters are planned, one on March 27, 2025, and another on June 19, 2025. These flybys will bring the spacecraft nearly as close to the sun as its record-breaking encounter, traveling at similarly mind-blowing speeds. These final missions aim to refine our understanding of the solar corona and test key hypotheses about its heating mechanisms. The data Parker collects has profound implications not only for solar physics, but also for our broader understanding of the universe. By studying the sun up close, scientists can develop models applicable to stars of varying sizes, ages, and compositions. Closer to home, Parker's findings could enhance our ability to predict and mitigate the effects of space weather. Solar storms originating from the corona can disrupt satellite communications, damage power grids, and endanger astronauts. A deeper understanding of the corona could lead to more accurate forecasts, helping protect critical infrastructure on Earth. Parker's journey is a testament to human ingenuity and our unyielding desire to explore the unknown. Its record-breaking speeds and ability to withstand the sun's intense heat embody the spirit of innovation that defines space exploration. As the spacecraft continues its mission, it brings us closer to solving some of the cosmos' most enduring mysteries. On Christmas Eve, as Parker raced through the sun's corona at nearly 700,000 kilometers per hour, 430,000 miles per hour, it carried the hopes and dreams of scientists, engineers, and visionaries worldwide. While the spacecraft itself may never return to Earth, the knowledge it gathers will illuminate humanity's understanding of the universe for generations to come.